Hello again, 7th graders. We are now in section 3.2, solving inequalities using addition and subtraction. So I have great news for you. Addition and subtraction inequalities are solved the exact same way equations are solved. So basically it's just like you're solving equations. You're going to use all those same properties, except they're going to say inequality after instead of equality. So we just finished graphing like p is greater than negative 2.3, and there was nothing else there for you to do. The variable was already isolated. In these, you need to isolate the variable first, and then we can graph it. So I will show you what I mean. Let's zoom into this first example here. It says p plus 7/10 is greater than negative 2 3/10. So I'm going to draw my line down from the inequality symbol. And just like normal, you want to get rid of this 7/10 that's being added. So you may look at this as subtracting 7/10 or adding the opposite. Either one is correct. They mean the same exact thing. This 7 plus negative 7/10 plus negative 7/10, sorry, equals 0, and p plus 0 is of course p. Negative 2.3 plus negative 7/10 ends up giving you negative 3. And now instead of putting an equal sign between the two because they're not equal, we're going to bring our symbol down, which was greater than. So there's our answer. P is greater than negative 3. To graph your solutions, because I do want you to graph all of these solutions, I'm going to scooch this over just a little bit. We're going to do exactly what we did in lesson 3.1. I'm comparing p to negative 3, so negative 3 is what I want to put in the middle. And I'm going to fill in digits on either side. So on a number line, negative 4, negative 3, negative 2 is what that would look like. And if p is greater than negative 3, that means that p cannot be negative 3. So it's an open circle. It can be all the values greater, though. So I will shade to the right. All right, next one. Ooh, fractions. I know they're your favorite, aren't they? Especially after Skill Packet 5. I bet you're just loving this. Okay, draw your line. And z isn't by itself. There's a 2/3 here with it. So I'm going to add a negative 2/3 or subtract 2/3, same thing. And then we have z on this side. I want to take 5/6 plus negative 2/3. What I personally would just change this because I see this as thirds. So negative 2 times 2 gives me negative 4. And 3 times 2 gives me 6. So I'm taking 5/6 plus negative 4/6. That was funny to say. So it's like saying wasps. 6ths. Anyhow, sorry. Too much coffee, of course. It's early in the morning for me right now. It's about 4:30. Alright, so add my numerators together. I get 1 because 5 plus negative 4 is 1, and bring over my denominator. I'll bring down this symbol, and it says that 1/6 is less than or equal to z. Remember before when this happened, I asked you to reverse it so that the variable was on the left. It just makes it a little bit easier to understand when you're graphing. So z and 1/6 are being compared. It opens up to the z, so I want it to stay opened up to the z when we rewrite it. So z is greater than or equal to 1/6. Now we're going to graph it. Put 1/6 in the center. Try to zoom out a little bit. Okay, and then I think I'll just count by sixths. So this would be 0, and then 1/6, and then I would have 2/6, right? And 2/6 is actually 1/3. So there's my number line. Z is greater than or equal to that, so I'm going to fill in a closed circle on the 1/6 because Z can be 1/6, and it can also be all the values greater than it. Okay, now we have another one with a decimal in it. Fractions and decimals are our friends. Draw your line down, and this is m minus 3.8. You need to understand that that means that that's a negative 3.8. Subtracting 3.8 and adding a negative 3.8, same thing. So to get that negative 3.8 to cancel out, we're going to add a positive 3.8 to each side. Negative 3.8 plus 3.8 are gone. They equal 0, and m plus 0 is m. And when you take 5 plus 3.8, yes, we're going to get 8.8. Drop down your symbol so it's less than or equal to, and m is already on the left, so we're good. So m is less than or equal to 8.8. Let's graph it. I'm going to write 8.8 in the center And whenever I see tenths place, I just usually like to go with it. So that would make this 8.7, and that would make this 8.9. It says that m is less than or equal to. That means I'm going to use a closed circle on the 8.8 and shade all the values that are less than that. So less than means to the left. All right, one more of these, and then we get math story time. Favorite time of the day. All right. So this means y minus 1/4 means I'm adding a negative 1/4. To cancel that out, I need to add 1/4 to each side. So that means I have my y here. 1/4 plus 1/4 is 2/4, right? And 2/4 we know simplifies to 1/2. And I'm going to drop down my symbol. Again, whenever I see the variable on the right-hand side, I just want it on the left. It makes it so much easier. So if it's opened up like it's going to eat the y, I want it opened up like it's going to eat the y. So y is greater than 1/2. To graph this, we're going to put 1/2 in the center. And I think I'll just count by halves. So this is a positive 1/2. That would make this 0. That would make this 1. If y is greater than 1/2, it means it can't be 1/2. So I'm going to use an open circle on that. It can only be values greater, so you need to shade to the right. Okay, boys and girls, it's time for a math story. Actually, 2 math stories. Very exciting. All right. Everything in math always seems to start with on a train, and then you know, oh, this is going to be awful. I'm just kidding. It's not, though. On a train, carry-on bags can weigh no more than 50 pounds. Your bag weighs 24.8 pounds. Write and solve an inequality that represents the amount of weight you can add to your bag. Okay, so I know you're thinking, well, can't I just subtract the 50 and 24.8 and get an amount? But yes, you can get the exact amount, but it says that your bag can weigh no more than 50 pounds. So that means there are all kinds of weights you can add to this 24.8 to get up to 50. So there's more than one answer. That's kind of how we know it's an inequality. So those keywords, no more than 50 pounds, kind of brings us back to that first lesson that we had on this with all those different vocabulary words and what it represents. So no more than means that the weight right here, it can be equal to, but it can't be more than 50. That makes it less than or equal to the 50. Okay? So your bag weighs 24.8 pounds. It's allowed to weigh 50. Write an amount to represent the weight you can add to your bag. So I will use W for weight. Why not? I think we use X way too much. So let's use a W. So basically, my current bag weight is 24.8. I can add a certain amount to it. And this amount here can be no more than 50 pounds. Now, if you use the commutative property and you wrote W plus 24.8 instead, that's fine because the commutative property has got your back. You're allowed to do that. But basically, this expression here represents the amount of weight we can have for my bag to be less than or equal to 50. So you solve these just like the others. I would add a negative 24.8 or subtract 24.8. However you look at it, it's the same thing. And W is less than or equal to. When you take 50 minus 24.8, you get 25.2. So the weight of the bag can be less than or equal to 25.2 pounds. And we, of course, want to graph this. I know when we see non-whole numbers, what do? It's no big deal. There's a tenth here, so I'm just going to write 25.1 here and 25.3 here. So the weight of the bag can be less than or equal to. That means it can be 25.2, so I'm going to fill that in. And it can be these values less. All right, last math story for today. I know, it's sad. You have raised $225 for charity. You go. That's awesome. Your goal is to have raised at least $600 though. So I want you to write and solve an inequality that represents the amount of money you need to raise to reach your goal. So you currently have $225. You want to have raised at least $600. So that means your amount needs to be $600 or it can be more than that. It's just the lowest it can be is $600. So we have $225. I want to know how much more can I raise. So how about A for an amount? so that the amount that I have is greater than or equal to 600. Because this amount here needs to be at least 600, which means it can be more than or equal to. And again, if you use the commutative property and switched it up and wrote a plus 225, that is just fine. So draw your line. We're going to add negative 225 to solve this, or subtract 225. I know you're probably sick of me saying that, but I know it's a question a lot of people have, so I keep saying it over and over again. That equals 0. 0 plus a is a. And when you take 600 and you subtract 225 from it, you get 375. So that means the amount that you need to raise still needs to be $375 or more. To graph that, I'm going to put 375 right here. And if you wanted to, yes, you could write 374, and then you can write 376. I think I'll count by 25s this time. And I'll put a 350 here and a 400 here. We're dealing with larger amounts, why not? It's not wrong if you wrote 374 here and you wrote 376 here. I'm just trying to get you to see that the number scale is kind of up to you. As long as the center point has the amount that you want to use, you're good. So if a can be greater than or equal to 375, that means it can be equal to it. So I'm going to fill in that circle, and it's pointing me to the right as greater than. So this represents all the amounts that you can raise. See you tomorrow.